Hey, welcome everyone into the NGK Tech Garage. Today we're going to be tackling what's probably one of the hardest things to diagnose on a vehicle that comes into the shop, an intermittent concern. Intermittent concerns can really be across the board, with, I don't know, intermittent radio concerns or intermittent drivability concerns or intermittent noises. They all require a special set of tuned skills to be able to figure out what it is. So what we're going to do today is we're working on an 09 Kia Rio that has an intermittent stumble stall type of concern. It kind of runs rough once in a while and stalls out once in a while. So that's what we're going to be working with today. So I'm just going to work through with you guys the process that I take when I'm looking at a concern like this. So that way we use our time most efficiently and we make sure that we're capturing the right type of data to lead us to the result or lead us to the root cause of failure without missing it. Because the worst thing we could possibly do is take this vehicle out, try to duplicate the concern, but have no way to capture the data from that test drive or from idling in our bay either way. Because then really what was the point? Sure, you've duplicated what the customer said it is, but what failed? What caused the failure? What has happened on that vehicle to cause it to fail? So, like I said, we're working with a 1.6 liter manual transmission Kia Rio. This thing's got 78,000 miles on it. And the complaint from the customer, it's, just like that typical throw the keys in the little envelope, drop it through the drop slot after they drop it off after hours. They say the car runs bad sometimes. The engine died at a stop sign once. It didn't do it on the way here, and the check engine light's not on. Okay? So that's like what you would normally end up hearing, like I said, written on that little envelope through the drop slot. Talk to your customer on this thing. In talking with him, he's already installed his own new fuel pump. Luckily, there's a little access panel in the back on this one, so it was super easy, but it is a decent amount of money to put a fuel pump in this thing and not fix the problem. It also has a set of new spark plugs under here. 78,000 miles is probably about due for him anyway, so we'll call that preventative maintenance, but again, it did not fix the problem that he's dealing with. So the way I approach these is pretty much the same every time, and that leads us to the most repetitive diagnostics. Now, you have to take your experience into account. So let's look at some of the tools that we use that maybe we don't know that we're using. So first and foremost, we deal with our experience. I think that might actually be spelled wrong. Anyways, we deal with our experience. It just looks funny. Deal with our experience. This is where we've diagnosed a car like this before, we've diagnosed a problem like this before, or something like that we're working with that we've seen before, or experience tells me that I'm not going to be looking at a starter condition or concern. I'm not looking at a battery concern. I'm not looking at a single cylinder concern, because I can run this engine on 3 cylinders and probably even 2 cylinders all day long. It'll run like crap, but it's not going to stall out. It's never going to die with those conditions. So experience tells me that I don't have to look for those types of concerns. By narrowing down our list and taking off what we don't have to look at really helps us get a clear picture of what we want to look at. Next up that we need to do, and it's highlight or bold here and underlined, the customer. Talk with the customer. Too many times in the shop we have that middleman, that service writer, and there are great service writers out there who will give you the exact information that the customer tells you. And then there are other service writers out there who, it's like that game of telephone. The customer tells them something to the service writer, and then it gets down to the tech, and they leave information out that maybe they didn't feel was important. It's best for the tech to talk directly with the customer. In talking with this customer, he told me that the vehicle stumbles sometimes, like it feels like everything just kind of shut off and then it came back, like almost instantly. When he's driving down the highway on his way to work. He's got a 35-mile commute one way to work. So that's telling me the engine has to be warm for this to happen, right? It's not on initial backing out of the driveway. It's not on anything like that. So that gives me some information. Maybe the service writer wouldn't have included that he has to have a 35-mile commute. So then we wouldn't know if it had to be warm or not. The other side of this, the customer told me that when this car stalls out, when this engine shut off on him, it wasn't like that running out of fuel where like you run out of gas in the car and it kind of stumbles and sputters and stumbles and tries to catch, and then all of a sudden it dies because it's dry at that point. It wasn't that kind of stall condition. The customer described it as it was like somebody shut off the key. It was an immediate die. The engine went from running what felt like perfectly to stalled out, not running anymore. He described it as it feeling like the key shut off. Now that's a lot different than diagnosing a concern where like maybe we're thinking the fuel pump went bad. Well, if the fuel pump went bad, yeah, it'll stall out, but it'll kind of sputter and it'll kind of run bad and then it'll die. If I'm looking at a stall concern like this customer described, the fuel pump's really not on the top of my list because we will be able to maintain fuel pressure for a few seconds after, maybe a second or two after the pump is shut off. That vehicle will continue to run and it'll run poorly until we don't have enough fuel pressure to keep the engine running. So we get that stumble out and die. We don't get that immediate shut off like the customer described. Eyes and ears are huge diagnostic tools for us. Look for things, pop the hood. Even if the vehicle's been parked out in the lot, before you even take it for a drive or hook any tools up, pop that hood out in the lot, look for something that's out of place, right? Does it have the 00 battery wire hooked up to a big amplifier in the back that every time he turns his music up really loud, the car stalls out? Well, that's the type of stuff that we can see. Does it have a giant mouse nest under the protective cover? Does it have really corroded battery terminals? Is like the strap here going from engine to chassis ground, you know, is that strap right here, is that corroded and torn? Visual inspection and then using your ears once you get it running, listening for certain things. Really helps pinpoint a direction to maybe go with this thing. Is it running great all the time and only stuttering and sputtering part of the time or stalling out part of the time, or is it all the time? Then it wouldn't be an intermittent condition and we wouldn't be talking about it right now. As for the scanner, great tool, full function tool. We can actuate things, we can check codes, we can look at data. I'm going to go ahead and flip the key on and we'll check for codes in here, and I believe we will see 0 codes. The customer did say that the check engine light had been on and off for a little while, took it to the local parts store, found out that he has an evap small leak condition. So not anything we're really going to bother looking at this moment because it could just be something evap related. But we're going to look at codes, our code list, no codes present. There we go. So we can look at data, we can do actuation tests, and we'll get to that data in just a little bit when we start working through this. Our lab scope, really here, the more channels you have, the better. This gives us the ability to watch sensor or sensors over time to actually catch that failure happening, right? The worst thing that you can do is have it happen and have no data to look at. The lab scope will give us the data coming out of those sensors directly to be able to see what it is that we're looking at. A multimeter might be able to capture the data, but we're not able to capture it and look back, right? You throw this multimeter on here, and let's say we lost power to all of our ignition coils at the same time. It'll go from reading battery charging voltage down to 0, but we don't know if it went down to 0 because the engine has shut off, or if it went down to 0 before the crank and the cam sensor stopped spinning, right? Before they stopped doing what they were supposed to. So we don't know exactly when it happened or how it happened. We just know that it happened with a multimeter. It's going to tell us what's happening at that very second, but it's not going to be telling us what happened 10 seconds ago or 20 seconds ago when the problem occurred, okay? The lab scope is going to be your friend here. So I have the Pico scope with 4 channels that we're going to hook up today. I also have the little U scope here. Great tool, so if you don't want to have to invest a lot of money into a lab scope, go ahead out to AES Wave and pick one of these things up. This is a great little tool to grab a single channel. So we're going to just grab a single channel of the crank sensor today with this guy along with the Pico, just to show you guys how it works and how fantastic of a little scope it is to capture a single channel. And then don't forget about the internet, guys. Repair information, obviously your friend, you know, All Data, Identifix, Mitchell, OE service information, look for TSBs, look for that kind of thing. Google forums and Facebook groups. As with everything that we always talk about, there's information in there. Just make sure you vet that information, you weed out the bad stuff. You know, if you hear 1,000 people out there talking about fuel pumps, well, maybe that's why this customer put a fuel pump in this car already, because the forums had told him that they're a common problem. And maybe it is a common problem, but it wasn't the problem that he's dealing with right now. So just make sure that when you're looking at any sort of that stuff on the internet, it can lead you to a repair. Just make sure that you vet that repair, that you make sure that that's actually the root cause of the failure, because there's nothing worse than throwing a fuel pump in a car and the customer coming back a week later with the car stalling out still, right? Then we look like we're not doing our jobs good luck getting paid for it the second time. So from there, we have the tools that we need. Now we have to decide what it could be and what it isn't. So I like to lay it out by the 4 things the engine needs: fuel, spark, air, and compression, right? We need those 4 elements to create our combustion event to make our engine run. So we'll start with fuel. Fuel pressure. We already talked about this a little bit. Fuel pressure, if we lose it, it might die or it will die, but it isn't going to happen immediately. It'll be like running out of gas. It'll sputter and stall. So fuel pressure is something that we can watch on newer cars especially. We might have a fuel pressure sensor. GDI engines are really great for this, that we can watch it. This vehicle, unfortunately, is still an older MPI engine. No Schrader valve on the rail either, so there's no easy way for us to look at fuel pressure on here. My gut says that it's not fuel pressure related, so I'm going to move that down the list. I'm not going to take it off the list at this point. If my other options strike out, we'll look at fuel pressure. Injectors being clogged, dirty, or leaking? Could be. What are the odds of all 4 or 3 of the 4 injectors causing a problem at the same time? What are the odds that there's a piece of rust floating in the rail and clogs up all the injectors at one time? Maybe for a single cylinder misfire, we might just affect cylinder 1, but to affect all 4 at the same time with a dirty or clogged or leaking injector, unlikely. Also, if we have a leaking injector, we can look at fuel trims, see if they're skewed, if they're running rich. If the engine's running rich and it's pulling fuel away, we could have a leaking injector. Fuel control. Are we turning the injectors on at the right time? Are we keeping them on for the right amount of time? And then wiring issues. These are ones that I want to look at, because if we stop turning the injector on, if we're not controlling the injector, we could end up with our problem. Fuel quality. If we have water in the fuel, E85, if somebody filled this thing up with diesel fuel, is that going to cause our problem? Well, generally speaking, those will not be intermittent concerns, okay? If it mixes with water, if it has E85 or diesel, that'll be a consistent concern. We would be able to see a lot of that with fuel trims. You'll usually end up with like a lean coat or something like that, or it might not run at all with diesel in there. So we're not going to be pulling a fuel quality sample on this engine right now. All right, let's get down to spark. So we could have a poor spark quality, right? This customer's already put in new plugs, so I'm not really worried about worn plugs. The problem hasn't changed since he installed his spark plugs. It's still the same, so I'm not looking at maybe the improper spark plug being in that cylinder or something like that, because the problem has been there before and after. Bad ignition coil or coils. Sure, it could have a bad coil. I mean, working on Kias, we've put coils in cars, right? They fail. But what is the likelihood that 3 out of the 4 or 4 out of the 4 coils all fail at the same time? If 2 of them failed at the same time, it's possible, right? I mean, unlikely still, but if 2 of them failed, this engine would probably still run on just 2 cylinders. So we're looking again at something that affects all of them. I want to look at spark timing and wiring as well. So we got to make sure spark is happening at the right time. We want to make sure that the wiring is okay. We can verify the PCM driver. And we're going to use, for both spark timing and fuel timing, as well as the wiring, we're going to use current for both of those. And I'll explain how we do that in just a minute. But we're going to use the current that those individual components draw with 1 channel on our scope for fuel, 1 channel on our scope for spark. So we're taking up 2 of our 4 channels, looking at our ignition coils, all 4 of them, and our injectors, all 4 of them, okay? Make sure comments are going good. Just swap out the engine. Dying fuel pump, there usually is no codes. That's true. Nick, with a dying fuel pump, you could actually run into a lean code potentially if the fuel pump isn't putting out what it's supposed to. It might be adding injector pulse width to keep that fuel into the engine. Joe just got his first scope a month ago, a used scope. Awesome, Joe. I hope you're loving it. Looks like there's quite a few people here that have a used scope. So cool. It's a great little scope to use. Super simple for setup and to get it out. Sorry, Chris, I'm not starting over. Just go back to the beginning. Let's see here if there's anything else. Loss of 5-volt reference. Yep, Neil, you're bouncing ahead a little bit, but yeah, that's a really good point, is a loss of 5-volt reference, and we'll get to that in just a minute. So let's get back to air. Now, we have to be able to monitor or measure the amount of air that enters the engine, because that's vital to decide how much fuel to put with that air to create our explosion. Now this vehicle here, airbox, air intake snorkel or air intake tube, whatever you want to call it, to the throttle body, this is a not a mass airflow sensor vehicle. This is a MAP sensor vehicle. So I do not have a mass airflow sensor in this intake snorkel. So on this vehicle, this specific 1.6 liter, I'm not looking for a torn intake snorkel boot or whatever you want to call this, intake tube. I'm not looking for a tear in there. If this was a mass airflow sensor vehicle, super common for some of these ribs here to tear in between. And then when you torque the engine, either in reverse or going forward, this engine here will shift and this thing will move forward or backwards. We're going to stretch out this air intake tube. We're going to open up the accordion there. We're going to draw in fresh air that's not being monitored by the mass airflow sensor. Suddenly we have way more air than we accounted for fuel, and we'll end up with a rough running, stalling potential condition. But MAP sensor on this engine, I don't really care about anything that's happening from the throttle blade here to the air filter. Now, if it were a dirty air filter or a plugged up air filter, or if it's the middle of winter and the air filter's got water in it and it froze solid, that's a different story. You know, pop the clips off quick, take a peek at that air filter. But if we have like a bag or something stuck in the air filter box blocking our flow, that's going to be more of a consistent problem, not a very intermittent problem like he's dealing with. But basically anything from here to here that could choke out the engine and not allow airflow between these 2 points. But again, on this one, all of our sensing happens on the intake manifold side after the throttle body, on the side that has vacuum, a MAP sensor. So we could run this engine perfectly normal without the air intake box on there. So a little bit different than a mass airflow car. If it's mass airflow, look for a torn intake boot. And then we have to make sure that we're monitoring the air properly, so we want to make sure that our MAP sensor itself is actually working. So what I'm going to do is we'll go ahead and pull up the data list here on the scan tool. You'll see that we got quite a bit of data. This is a pretty basic car. In fact, this is an 09 that has no power steering, no air conditioning, manual transmission, manual windows, manual locks. It does have a blower motor, so that's nice. So it's got heat, but very basic vehicle. But you can see we have quite a bit of data here. I'm just going to grab a custom list, and as we're talking through this, I'm going to grab some stuff. So I'm going to start off, we'll grab the MAP sensor. I think I might have passed it. And we'll go back through the list before we start the vehicle up. But what I'm grabbing now are things that make sense, and apparently I'm blind. There it is. We'll just grab voltage. We don't really need two PIDs for the MAP sensor if they're doing the same thing. We'll just grab the sensor voltage. EGR and VVT. They're kind of, if the vehicle's got one, it might not have the other. It depends on the vehicle. Some will only phase the intake cam. Some will use VVT on the exhaust cam like this one. This vehicle doesn't have an EGR valve, but an EGR valve could potentially cause our problem on a vehicle that did. If it were stuck open, when the vehicle returns back to idle, we're forcing way too much EGR gas into there, cause a stall condition. Is it likely to affect all cylinders? Depends on how that EGR is routed. If it's like an old Ford 3.8 or a Honda 3.5 or something where they have specific paths that EGR flows through the intake manifold and they plug up, right? They carbon up. Well, in those systems, we generally run into a single cylinder, maybe even a multi-cylinder misfire, but we don't usually run into a stall condition due to EGR on those vehicles. We would clean out the ports and it would be back to normal. But if we had an EGR valve that just ran a big old tube right into the intake manifold and that thing stuck open, could definitely cause a stalling condition. So EGR can cause stalling. Just make sure you understand what type of system you're working with. VVT can definitely cause our engine to run rough and stall. If this VVT solenoid right here were stuck in one position, it could cause us to stall out. It could cause us to run very poorly. It just depends on the operation. Now this is a single VVT on the exhaust cam on this one, so no EGR valve. It's doing some valve overlap with VVT on here. But what we can do is we can look at actual and desired for VVT operation and make sure that that's not our problem. Make sure that our our cam is where it should be. So we can do camshaft position, target, and actual, and that will give us a way to look at to see if the cam is being phased, at what percentage or what degree mark it's supposed to be phased to, and what it is actually at. If they differ, that could definitely cause our problems. So that's just messing with the air going into the engine. And then we got compression. Compression is one of those things that's usually not an intermittent concern. Cylinders low on compression, probably not an intermittent problem. If you have like piston sealing, ring issues, that kind of stuff, even valve sealing, burned valve issues, that kind of stuff, not really an intermittent concern. What's the likelihood that we have 4 burned valves on this engine? It's pretty unlikely. And even if we did, this thing would start up and run poorly right away. It's not going to be intermittent. Same thing with timing chain, timing belt problems. If the belt or chain stretches or wears or jumps, it's not going to jump back, right? It's not going to shift back a tooth. It's going to keep moving ahead. The engine only spins one direction. It's not going to ever work its way backwards. So if we're dealing with a mechanical engine timing issue, it's probably not intermittent. The only thing that we might see here that's intermittent are sticky valves, or valves that are holding up or floating or staying open. Something like that could cause an intermittent problem, but we would have to have something affecting at least 3 out of the 4 cylinders to cause this engine to stall. Plus, it would run poorly before it stalled. It's not going to be that immediate snap of the fingers engine shut off from running perfect. So compression really isn't something that we're going to look at here. But if you're thinking you might have an issue with compression on the engine for whatever reason, you can do a relative compression test where you take and throw an amp clamp around a battery cable, compare all 4 cylinders to each other, throw a gauge in a cylinder, throw a pressure transducer in the cylinder, and look at that compression over time. There's a lot of different ways to look at that, but we're really not going to address any of them today because it's not answering our question to our intermittent stall. Lastly, we got just some oddball things here. PCM internal failure. What if our PCM is intermittently going down? What if we're running into issues with that? We would likely have a PCM related code, maybe even a loss of communication in another module, saying that our PCM has gone offline. It could definitely describe our immediate shutoff if the PCM were to go down. If we were to take the entire network down, we would most likely have code stored in other modules as well, saying that our network has gone down. We've lost communication with the PCM, so maybe, what else would be on here? Maybe airbag module. Somebody else that talks to the PCM on the network would maybe show a network down type of code, or a lack of communication type of code. 5-volt reference going down, this is a big one. So a lot of vehicles, pretty common on Fords especially, where they run a 5-volt VREF circuit. It's basically the 5-volt supply to your sensors. If you drop that 5-volt supply that's generated by the PCM, you could lose all those sensors' outputs. Okay? So that could be a problem. A single sensor could take that entire 5-volt VREF circuit down. If you have a relay turning off, it could definitely be your problem if a relay is intermittently opening its circuit. If we have sensor dropout, just like 5-volt VREF going down, if our sensor suddenly drops out, could cause our issue. And then this vehicle still does use idle air control. So if our idle air control had an issue, it could definitely be causing an idle problem, but that's not really going to describe his or be the problem for his driving down the road stumble condition that he was seeing on the highway. So we got a couple things on this screen here that we might want to look at that we can throw some data on the scan tool for. So I'm just going to start at the top of our list. Don't need these. We'll just work through. We'll grab ignition switch, because if the ignition switch is suddenly reading off, well then we got a problem. Fuel cut is going to be, like if you go wide open throttle, let off the gas, it might go into fuel cut. We're not too worried about that. Grab cranking signal, grab MFI control. Engine running status, well that's pretty obvious. I don't think we need that one. Either the engine's running or it's not. Why don't we care about oxygen sensors? Oxygen sensors are a post-combustion event monitor, right? They watch whatever happened in the combustion event. So this oxygen sensor right here is going to adapt or be an input to adapt the fuel control for our engine. If our oxygen sensor were to have issues front or rear or wideband or standard traditional style oxygen sensor, if it were to have issues, we would probably set a code, and the vehicle most likely go into open loop. You can short that sensor out, feed 0 voltage to this thing when it's running wide open down the road, and it should go back into open loop before it stalls. Open loop fuel control will just go off the tables that are based inside of the PCM. It'll no longer use that closed loop, that oxygen sensor. So I don't really care about looking specifically at O2 sensors. Plus, I can use my fuel trims to get a good judgment of what is being done based upon the inputs from O2 and temp sensors and that kind of thing. So we can use that to our advantage. Canister purge, could possibly be a intermittently stuck purge solenoid, maybe. Let's grab it anyway. We'll grab TP. We'll grab engine coolant temp just so we can see how warm the engine is. I think we can skip a lot of these. Oh, there's our fuel trims. We'll grab those. Okay, so we'll grab those. Let's just take a look at the list of sensors that this vehicle has. Actually, let's look at the diagram. That'll give us a better option. So up on the screen right now is, there's 4 diagrams in here. So before I talked about looking at the injector current using an amp clamp. So what I've done is I've pulled out our 15 amp fuse right here, put in a fuse jumper lead, and I'm going to throw an amp clamp around here. What's cool is I will see the current being drawn by all of these components. So canister close, or the vent solenoid, the VVT solenoid, injector 1, IAC, injector 2 through 4, and the purge solenoid are all powered up by this one fuse. So when I take an amp clamp and put it around this fuse jumper lead on this 15 amp fuse right here, I'm now able to see the current that each of those components is drawing on my lab scope. So I'm going to go ahead, we'll hook injectors into channel 4. We'll work our way backwards. So that's diagram 1. Let's go to diagram 2 and see if there's anything in there that we want to look at. Because really what we're doing right now is we're determining what is worth looking at, what is worth capturing data on with the tools and equipment that we have to be able to capture this concern when it happens. So in this diagram, O2 sensors, talked about those, don't really care about those right now. Cam sensor, huge input to the computer for fuel and spark timing. I think we want to grab the cam sensor for sure. We'll throw that on the scope. Fuel tank pressure sensor, probably not an issue. Going to be used for the evap system, not really going to be used for our control. Could potentially take down the PCM if it were failing, but we're not going to grab that right now. Map sensor we have on the scan tool, throttle position on the scan tool. Crank sensor, another good sensor to grab. This is a 2-wire, so we'll look for an AC signal out of this. We'll look for a digital square wave out of our 3-wire Hall effect here from our cam sensor. And then a knock sensor, which is going to be used to detect detonation, which will change our ignition timing, but really probably should not be causing our vehicle to stall. So we're not going to use up a channel on that. So we have all 4 channels on the scope filled now, right? Cam sensor, crank sensor, injector current, and then I believe it's the next diagram we will see the ignition coils, which will grab current for those. Ignition coil 1, 2, 3, and 4, going back through a fuse ignition coil 15 amp in the IP junction box. This is the instrument panel box. So I've already pulled the fuse out, put a fuse jumper lead in there to grab the current for those. Don't really care about the cluster. Don't really care about this front wheel speed sensor. Interesting that it's got a speed sensor without ABS. It's probably using this for some sort of vehicle speed, which is kind of an interesting observation. And then diagram 4, I don't think we're going to look for anything in there. Besides, we're kind of running out of controls at this point. Fuel pump has already been replaced, so I'm not going to go after that right away. That might be something we scope later if we don't find the problem. We don't have power steering. We don't have AC. Coolant temp sensor we're looking at with the scan tool, and again the cluster there. So we're good to go here. Let's get these signals hooked up, and then we'll get this thing running. So I'm going to hook channel 1 into the crank sensor. And fortunately on this engine, the crank sensor is actually really easy to get to. It's right on the front of the engine here by the transmission, kind of a little bit behind the exhaust manifold, but I'll be able to grab a shot in there once we get that far. But there's a connector that's nice and exposed here for us to get scope into. So if we look right here, where my hand is the connector for the crank sensor, and it's got 2 wires. So we're just looking for an AC signal. I'm just going to grab one of those there. We get to the cam sensor. That guy is up top. We'll grab channel 2 with the cam sensor. Now, even without looking at a diagram, we have 3 wires here. I'll normally take a stab at the middle pin first. That's usually the signal output. Not usually. That's signal output a lot of times. You can get the diagram out, sure. Not a problem. And if we looked at it again, I bet I'd know we'd find the signal wire coming out of the middle pin. But sometimes it's just quicker to pin it and see if you have output on your lab scope. And then our last amp clamp, again, we're going to put instrument panel inside of the vehicle. All right, so again, we're key on right now. And now we've got 4 points of data that we're collecting for this intermittent condition, plus we're collecting a ton of data on the lab scope, on the scan tool. And let's hook up the U-scope as well, because why not? We'll throw that right there. And we'll just we'll take a couple different ways to look at the crank sensor here. We'll throw a meter on it as well, just to show the drawback of some of the equipment. All right. There we go. All right, that's in. That's good to go. Perfect. So let's get the scope open and take a look and get that set up. Now when we're dealing with our lab scope, Pico's really good for looking at intermittent conditions that are long-term. That really, we want to graph a ton of information right now so that we can stop the scope when the problem happens. So I'm going to go with a long capture. We're going to go 10 seconds per division. And what we're going to do now is we have 1:40 on the screen. So we have 100 seconds on the screen. What we're going to do, instead of allowing this thing to run the whole screen, refresh onto another screen, we're going to run a trigger on here. And we did this in the lab scope class, but we're going to keep this thing from refreshing. So I'm going to put this over here. Let's go ahead and up our voltage level here. I'm not sure what this sensor is going to put out exactly, but we want to put this single trigger somewhere where the scope will never see it. And then it'll always run to this mark, and it'll never refresh the page. So that gives us about 80 seconds or so to go and hit the space bar or pause the scope to be able to look at what we just captured. We're not going to be able to capture multiple windows here. We're not going to have multiple windows of our buffer, but we will be able to capture everything. So we're going to turn on all 4 channels, like so. Channel C is going to be one of our clamps. Now I could have all this set up ahead of time, but I just like to be able to do this live so that you guys can see that even though it's a lot of setup, there's a lot of things going on here, the actual setup time to make this happen, 5 or 10 minutes of looking at diagrams, getting the tooling out and setting it up, okay? We're a half hour in right now talking through some of the theory, but really a lot of that stuff happens inside of my head as I'm bringing the vehicle in, as I'm looking at the repair order, as I'm talking to the customer even, determining what I want to look at. I start to pick out what I want to see and what I don't really care to see at this time, maybe later, and then what I definitely know it's not, okay? And maybe in the beginning when you're looking at intermittent concerns, you get out a piece of paper and you say, write down, this is what it's not. There's no sense in looking at this. This is what it's probably, or this is probable, and this is less likely, but not worth putting in the not category. If you lay it out that way, you kind of give yourself the best plan to tackle what you need to tackle. The only problem then is duplicating the concern. So back to the scope, setting it up, we'll go 0 to 10 amps on both of our amp clamps, 20 volts on our AC signal, and then we have a single trigger. We're going to go ahead and up our sample rate. We'll just bump it up to the max. So we're going to capture as many samples as we can. So we're capturing 25 million samples at 4 microseconds per interval. So we're capturing a super fast sample right here. Now, I don't know if anybody noticed here, but our blue line right now is not sitting at 0. Engine's not running. We're into an AC signal crank sensor. We're into a crank sensor right now that generates its own AC voltage when that tone ring passes by it. Why are we sitting at not 0? We're currently sitting at we'll call it 2.1 volts, right about there, 2.1-ish volts. Our meter's not reading anything, right? If we look at the meter, it's reading 0. This is the difference between AC and DC. So if we were to put the scope on AC, we would read 0. If we go to the meter right now, put it on DC, we'll go from 0 to that 2.1-ish mark, okay? The only thing that really matters here is understanding where your 0 line is. So our AC signal out of our crank sensor right now is going to ride at 2.1 volts. That's at 0 mark. It's going to go above that and below 2.1. If we switch the scope to AC, we will see that signal drop down to 0. There we go. So now we're down at 0, and our AC voltage is going to go above and below the 0 mark. Okay, we're filtering out the DC. Now, I don't really ever turn it on AC just because the picoscope allows us to just zoom in and see everything that we want to see anyway. But if we're measuring amplitude on the signal, if we're measuring how many volts it achieves, positive and negative, we have to remember that we started at 2.1 volts and not at 0. Okay, we kind of have a floating 0 mark in there. That's where we're going to zero this out from. I do have the U-scope, I believe, set up. We're 2 seconds per division. 2 volts per division. So we should be good there. I think you guys can probably see it. So we'll see what that looks like. On our scan tool, we have all our data there ready to capture. It's currently in graph mode. We can see everything there. I think now it's time to start this thing up and see what happens. All right, so it starts right up, like perfectly. I mean, that's nothing I'd be worried about. Our map sensor dropped down to 1.5 volts. I would assume that to be roughly idle vacuum. You'll see our cam actual position is shifting a little bit, but we're at like point percentages here, so nothing I'm too worried about. Coolant temp's coming up like normal. Short term, it's running a little bit, it was running a little bit rich there. Could be a cold start strategy, that it intentionally runs it a little bit rich when it's cold to feed the cat with some fuel to, to get it operational. Everything else on here appears pretty normal. Our scope right now is capturing a ton of data. If we look, we're bouncing off the trigger right now. That's why it's looking like that. That you just need to make sure that whatever channel you're triggering off of, right now we're triggering channel A, you need to make sure that it's not ever going to hit the trigger, and then you'll be able to make your scope do this. So now I have been able to actually make this thing stall out, or have it stall out when I was prepping for this class in the bay here just idling. So we're going to let this thing idle, warm up, and we'll just play with all our different options here of what we're looking at while we're waiting. So here's our signal on our U-scope. It's a great little signal there. Looks really nice coming out of our crank sensor. We can even zoom out, see more. We can zoom way in. So a nice clean AC wave on there. That's what we're seeing on the lab scope right now, but it's just very, very zoomed in. But that's what we're looking at. Our voltmeter is giving us AC voltage, about 3 volts, which is what we expected to see. If you look at the lab scope right now, see how it slopes downwards here? As our engine's warming up, our idle is consistently lowering. So our actual RPM is going down as the engine gets warmer. That's why we're seeing a slope in here. I'm gonna go ahead and really quickly pause this just to show you guys what we're looking at. Hopefully it doesn't stall out when I'm in the pause. So green, right there, is channel 3. That's our injector current. So all of our injectors are working. Yellow is our, green is ignition coil current. Yellow is injector current. So all of our injectors and coils look to be working. Red is our cam sensor, nice square waves there. And then blue, if we zoom in, blue is our crank sensor. So beautiful looking crank signal there, just like we saw in the U scope. Everybody right now looks happy. This is a really nice looking pattern. I don't see anything in here that leads me to believe we have an issue currently. And judging by the way the engine is running currently, I'm okay with it. I'm gonna go ahead and up our voltage on our cam sensor up to 20 volts since it appears to be a 12 volt cam sensor. We were peaking out before a little bit off of the 10 volt scale. So now everybody's on the screen, engine's warming up. Everybody on the scan tool looks happy. Our short term looks beautiful, hovering the 0 mark. Our long term idle load, perfect. Partial load is a little bit lean. We're adding fuel a little bit, but we're not under any load right now, so I'm not worried about it. Let's see if our throttle position sensor responds if I bring it off of idle. Okay. So if you see when we went under partial load there, our fuel trims went very negative. It's actually counteracting our long term. So if we kept this thing at partial load, we would actually see this returning back to 0. If we did a master reset, a clear of the stored memory, this would probably be much closer to 0. Everybody here is looking good. If we look at the lab scope right now, you'll see where we revved up the engine. As we increased engine speed, it increases the amplitude on our crank sensor, so we create more voltage. As the engine's going faster, our crank sensor, being a variable reluctance style, ends up increasing in amplitude or voltage, where our cam sensor, being a digital sensor, is always at that flat. This one happens to be at 12 volts, or 5 volts on some cam sensors. So that's why we're seeing that, but nothing to worry about right now. It seems to be running great. When I was playing with this thing, originally setting up this class, it took about 10 minutes or so of idling, and then the engine died. So we're a few minutes in, we'll keep taking a peek at things. Now the reason why I'm not looking at a really close capture on the lab scope right now is because I want to be able to get back to the lab scope before it refreshes, okay? Before we run into, oh crap, I lost it, it didn't capture it. It happened, the lab scope saw it, but I didn't get back to it in time to pause it. So I take a long capture, I can walk away right now, I can go work on whatever's in my second bay as this thing's idling, capturing all my data, and then I hear it stall out. I have right now, like 90 seconds roughly, minute and a half roughly to make it back to the vehicle to pause the lab scope to see what I saw. It also gives me, if I'm on a test drive, it gives me about that 90-second mark to get over to the side of the road to shut off or to safely view my lab scope, to pause it, safely view my lab scope. It gives me plenty of time to be able to see that. Same thing with looking at data on our scan tool. It gives us the ability to look back on what is happening. So just note here, this thing is actually purging at idle, so kind of cool. But we are purging at idle, but it's not causing our engine to stall out, so I'm not too concerned about a purge condition right now. This is looking all really good. So why don't we, while we're waiting for this thing to do something, why don't we do the t-shirt giveaway question quick? So everybody who sends me out an email today has the first 5 people to get it right has the opportunity to win a Diagnose Before You Triagnose t-shirt for free. If you've won already, I'm going to put your name at the bottom of the list and trying to get t-shirts out to everybody who hasn't won yet. But that's only going on today. First 5 people to send me out an email with the correct answer to this question here. 2 technicians are discussing a stall/rough running concern that only occurs after filling the vehicle up with fuel. The car will start and run poorly for a few seconds or so, and then, on occasion, after filling up the vehicle with fuel, it starts and immediately stalls. Who's pursuing the most valid, most time-efficient path? Technician A says to perform a fuel quality test. Technician B says check for codes, specifically looking for evap-related codes, evaporative emission systems codes. Both technicians or neither technician? And then please give me the reasoning as to why. Why did you choose that specific Tech A, Tech B, both, or neither? Who is doing it the most valid, most time-efficient way to diagnose this car? All right, so this is a scenario right now where the engine just stalled out and we weren't looking at it, right? Oh crap, now what? What just caused it to fail, right? So, again, 90 seconds to get back to the scope and hit my pause button. My scope captured what I wanted. My voltmeter doesn't have what I needed to. My U-scope, unfortunately, doesn't. My scan tool shows my ignition switch on, cranking signal off because the engine stopped running. Our MFI is still on, purge is off, map sensor's back to idle, fuel trims look normal, camshaft is where it needs to be. Coolant temps, warm, this engine's warm. So unless we were looking at our 4-channel scope right now, what do we see? If we don't look at our scope capturing our long capture, what exactly are we looking at? What caused it to shut off, right? According to our scan tool, our ignition switch didn't drop out. Our MFI relay stayed on. Everything on the scan tool looks completely normal. This is why we need to be using scopes to look at this kind of thing. Intermittent problems especially. We're able to see and record what happened. And in one of our 4 channels, I'm going to be able to prove to you guys that it has failed. What are your thoughts? Drum roll. Oh, can you throw up the t-shirt question real quick just so people can get my email again? So mcbecker@ngksparkplugs.com. Make sure it's plugs plural with an S at the end to make sure that it ends up getting to me. All right, and I'll actually put it in here as well at ngksparkplugs.com. There's my email. Okay, so drum roll. Who thinks they know the answer to our problem? What failed on here? What caused our caused our car to stall out and die? Did anybody notice when it died? I know it's probably hard to hear because I was facing this way. My microphone's right here. I could hear it. I don't know if you guys could hear it. But it wasn't a stumble, sputter, blah, 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 stall. It was a engine's off, right? Just like the customer described. It was an immediate stall. It wasn't a stutter, stumble, misfire stall like it ran out of fuel. All right. Ishman Garcia, sorry if I'm pronouncing it, crank sensor overheated, so it's a heat-related problem. Yes, Nick, perfect. It is a heat-related problem. The customer kind of told us that in the beginning when he said it happened on his 35-mile commute. The engine had to be warm. Losing crank signal, CKP, dirty throttle body. The guy hiding in the passenger compartment turning off the key. Well, I can guarantee you there's nobody hiding in there turning off the key. So it wasn't that guy. A dirty throttle body. Would a dirty throttle body cause it to stall immediately like that? I don't see how it could. Robert, if you don't mind, what are you thinking here? What do you think a dirty throttle body, how it could cause our stalling condition? I'm not disagreeing with you. I just want to know what you think. What's your thinking on that? I'm curious because maybe I'm missing something and we can learn something together here. All right, Ernest, I will show the capture. I just had to build up a little drama first, you guys. Okay. Anybody see it? Ruh-roh. That's not good. Our crank sensor went from fully operational, fully perfect. I mean, you don't get a crank sensor that looks better than that. I mean, really, that is a beautiful looking signal, to 0, to nothing, back to bias voltage. Now, how do we know that the engine isn't shut off and we're just not getting a crank signal then? How do we know that that's not the fact? Well, this big red square in here that's interrupting our crank signal, this tells me our engine's still running because we captured the cam sensor as well. Our engine is still moving. It's still turning at this point. It's still spinning over. It's still interrupting our Hall effect sensor for our cam signal. Oh, and then look at that. It came back. So our crank sensor, for whatever reason, ended up coming back. And then we get back into fuel injector and ignition control. So this thing would have cut off. Surprisingly, it stalled out and I didn't really hear it stumble at all, but it did come back. Now, what we would expect to see, should this have been a condition where the engine shut off, not caused by the crank sensor, I'm looking for something like this. Right here. This tail at the end here where we're reducing amplitude, that's kind of the engine spinning down. So after everything's been shut off, after we've stopped giving spark and fuel, the engine takes a few seconds, not few milliseconds really, to kind of spin down to stop the crankshaft from moving. There's not a break in there that makes it happen instantly. So our crank sensor will respond with a reducing amplitude style signal. So if we look close at that, you'll see we're reducing our amplitude signal as this thing slows down until we get to nothing. So let's see. We'll go back to capturing. Let's see if it starts up now. Okay, so it starts back up. Started up perfectly. Again, running beautiful. Crank sensor looks great on our U-scope and our voltmeter. Who's trying to run away? So I'm going to give this thing a little gas to try to get it warmer, see if we can get this crank sensor to fail consistently. So of course I'm not going to be able to get it to fail again because, well, that's just the way it goes when we're going live. Sometimes like a little bit of a tapping on the sensor can help. So we'll just try that. We'll give it a little tap here with an extension. Now, if we were concerned about a wire condition, one of the best tests that you can do is start wiggling stuff around. So if we're looking for intermittent problems, start wiggling stuff around under the hood. It's called the wiggle test. You know, wiggle the harnesses, try to figure out, you know, what's going on with this crank sensor harness. And of course, it's going to be working beautiful now. Well, I'm not going to waste a bunch of time here waiting for this thing to get hot enough to fail. What I'll do is we'll leave it run, and in the meantime, I'm going to show you guys what it looked like when it had failed. Oh, of course, there it goes. So I'm gonna leave the scope capture on right now, and we'll crank this thing over and see if it does anything. Oh. Okay. We had an extended crank that time because our crank signal didn't pick up right away. So let's take a look at that. So we'll look at our failure. Again, our engine, if we look at the cam signal here coming off the end here, according to the crank sensor, our engine has stopped spinning, but our cam sensor is still picking up a signal. So that's telling me that our engine is still spinning. So our crank sensor is lying to us at this point. Our crank sensor is saying the engine stopped spinning, I'm not sending a signal. So the PCM says, well, I'm going to stop controlling fuel and spark then. Our cam sensor tells us that the engine was still spinning. It was still doing what it was supposed to. If we look at, so here we're back to bias voltage, engine stalls out, everybody goes to where they would normally go. Here is our cranking. Ooh, that is ugly. Right there's our cranking signal. That's why we're getting an extended crank. And eventually here, I'm assuming we'll go back to a nice wave. So the red here is telling us that our engine is cranking. Our cam signal is doing what it's supposed to. It's giving us a signal. And nothing. Interesting. So has the vehicle gone into the ability to start without the crank sensor? Let's try that one more time. Let's try starting this thing up. So extended cranking time, but it does start and run. And when it starts to run, I really don't think we're getting a crank signal here. I mean, this is probably too messy for the computer to even see what it's seeing. So I would say that, judging by this thing, the computer's probably running without crank sensor operation, which would tell me, should tell me, that we now have a code for this thing. Because in order for the computer to ignore the crank sensor, it has to know that there's a problem. Look at that. Cool. So we got a code now. That means that this sensor is toast beyond toast. So let's, now, for those of you that have been watching my training that we do here for a long time, you know how little I use an ohm meter, right? Almost never. An ohm meter is a test that doesn't test under load in the system. It doesn't offer us a true test. But judging by the fact that we have a code right now and our sensor's really doing nothing, I bet our sensor's open. Yep, there we go. So if I cross my leads, prove out my ohm meter, beautiful. And now I'm on the sensor, nada. So our sensor's open. This crank sensor on here is toast. So what happened, the reason why it failed, is the sensor itself, it's basically just a big spool of wires, right? One terminal is connected to the other with a big long wire that's twisted around a bobbin. What happens is that sensor got warm, it expanded, and the big long train of wire in there just went open. It no longer is able to create a signal. It's no longer a path between the two terminals on this thing. So I think now we can go ahead and swap this thing out. Oh, look who showed up. Good to see you, Az. So let's take a look at what I've got here is got my little got my little borescope hooked up. So let's take a look at that crank sensor. So this is where it is. We're right down next to the exhaust manifold. So there it is. Judging by the way that thing looks, all nasty looking, I'm going to go ahead and assume it to be original. 78,000 miles on this vehicle. Could have been replaced early on, maybe. I don't know. But I'm going to assume that it's original just because it looks so nasty in there. So now, is it going to come out, I wonder? And where's my flashlight? Downside is doing this live, I can't cut out the part where I'm like struggling to make sure my flashlight's in a spot that makes sense. And you know, when I break the bolt off, or you know, the sensor doesn't come out because it's broken in half or something like that, I don't get to edit that out. So let's see how this goes. I got a 10mm swivel socket right now on the bolt. I think it's on the bolt. Feels like it is. Oh, and the engine is very warm. Oh, yeah. Okay, maybe the swivel's not going to work out so well in here. Let's try a straight socket. There we go. Well, that's a good sign. The bolt's coming out, so hooray for that. All right, so it's a one little 10mm bolt, and hopefully sensor comes out. Now, being that it's mounted into the crankcase on here, I bet there's an O-ring on this sensor that's binding up. It is stuck. Oh, wow. Why don't you want to come out? We might not be getting this thing out, guys. I might have to do this off camera. Can't do any cursing on camera. Oh, maybe? Oh. Hey! Look at that. So yeah, there's no O-ring on here. What if the O-ring's still down in the hole? Yeah, the O-ring's still down in the hole. Okay, so here's a good little lesson. Let's grab our borescope again. If you're messing with anything that goes into the block or in the cooling system or anything like that, never forget to look for a seal of some kind. If you try to shove the new sensor in here, it's not going to want to go in because I've left the O-ring in the block, okay? We got to pull that thing out. Get that out of there. Sorry for the jittery. My hands are kind of shaky. We got to get that seal out. Now, if we were running into a... Bring that back up for a second. If we were running into an issue where a crank signal was messy, where it had a consistent dropout every single engine revolution, we would want to be looking at our tone ring here. We want to look for maybe a crack or something like that on here that we might be able to see if we spin the engine over by hand and watch with the borescope. But we're not dealing with that today. So, magic sensor appears, right? So this is an NTK EH0013 crank sensor. I always talk about these a little bit, but it's just nice to pull a sensor out of a box that's in a sealed bag. I know this thing hasn't been installed previously and then returned to the parts store. You know, it's not, it wasn't part of a Diagnose type of diagnostic, right? So somebody didn't install this, potentially wreck it, and return it to the store. I know this has not been installed. So I'm going to go ahead and grab a pick and get that O-ring out of the block. And then we will get this new sensor installed. Now, because our time is crunched here, I'm not going to clean off the mating surface. There we go. And it's on the floor. But normally, if you're doing this, I guess I want to bring this back up. If you're doing this, you can see how rusty that surface is? You want to clean that surface up, okay? Now, I'll clean it up after we're done on camera today. But just so we can get this thing done, I'm going to go ahead and throw this in because I don't think that little bit of an air gap is going to cause an issue because our vehicle was running great before then. Any O-rings, a little bit of dielectric grease or something like that. I didn't have anything prepped, so I'm just going to grab a little bit of engine oil here, lube up our O-ring so that it goes back in nicely. We don't want the O-ring to be rolled over or anything like that. There it goes. Oh yeah, that's nice and warm. Gotta love it, right next to the exhaust manifold. Now, it feels like the sensor's hitting something. Probably the O-ring not going in all the way. All right, and bolt this thing down, and we should be able to fire it right up. Oh, yeah, that's hot. So if you're in the shop and looking at this thing, now is the opportunity to go up and sell the job to the customer and let the engine cool back down, because it is definitely toasty right now, especially being right next to the exhaust manifold. So get it snug here. Make sure everything looks good. Yeah, I think I'm gonna have to clean some of that rust out of there. It doesn't look like it wants to mount flush. We'll see if it works, and I'll clean it out after we're all done here. Okay, we're plugged in. Everybody else is plugged in. We're good to go. Let's bring up the scope. Go back to live. I am going to clear out codes first so that we don't continue to ignore the crank sensor. It would probably do it on its own after a couple key cycles. We'll go ahead and do a codes clear. Good to go. Okay. We'll make sure our ground is hooked up for our scope, or we're going to get an ugly looking signal. All right. Beautiful. Fires right up, doesn't have that extended cranking time. Our amplitude looks a little bit low here, most likely because I don't have it all the way threaded in. So we have an extended air gap right now because it is binding up a little bit. I need to clean out that hole that it's going into. I don't want to force it right now and break the sensor. I also have the red trace currently unplugged. But I'm going to shut this, actually, I'm going to hook red trace back up quick so I can show you guys what I was talking about when you actually shut the engine off. There we go. So when it's not the crank sensor dying out and you actually shut the engine off, it doesn't happen immediately, and you'll see that wind down out of the sensor. So we'll look really close here at the end, and you can see our sensor didn't just drop immediately. We reduced voltage or amplitude on this circuit until the engine stopped spinning. and then it went to 0. Okay, this is what we're looking for out of a good crank signal. We don't want it to drop immediately from a known good perfect pattern to 0 or bias voltage. What do we got for comments? All right, yes, an extended gap. In fact, I think we might even be able to see it with this thing, that I currently don't have the sensor buttoned up against the block, which is an issue. Now, I don't want to tighten this thing down all the way because I could potentially crack the plastic of the sensor. Oh man, hope I'm not making anybody sick. Yeah, see? So I'm already squishing my O-ring a little bit there. I got to get that hole cleaned out or I'm going to wreck my O-ring. So if it's binding up, if you're running into issues, you can see just how much voltage I had. I didn't have a lot, but it was enough to get this thing started up. So I'm going to pull that sensor back out, make sure I didn't just ruin my brand new O-ring, and get that thing all the way in. Hit it with your purse. Yeah. Yeah, so I think that is about it. No Floby. Thank you, Keith. Appreciate it. Magic parts appear. Yes, for sure. Does anybody have any questions? This is just, the way that I approach an intermittent diag. I need to make sure that I have everything in place before I bother even starting up the car, because that one time that it's going to stall out or cause the problem, you're going to have nothing on it. You're not going to have your equipment on it, and then you are going to be very upset that you didn't capture the data. So we want to capture as much data as we can that is relevant to the condition. So again, we kind of separate things off into tiers, decide what we're going to look at with a scope, decide what we're going to look at with a scan tool, decide what we're going to look at with our other scope if you're fortunate enough to own more than one. Whatever, really the more data that we can capture, the better, okay? All right, Keith, what's your question? It's going to be play a stump mic type of question. Nick, you're very right. Shops might have already thrown a lot of parts at this thing had it ended up there. This is one of our employees. He already put a fuel pump in it. Unfortunately, he spent a couple $100s on a fuel pump that did not fix the car. You mentioned that you didn't want to see the signal drop out immediately. If it were to do so, what would have dropped? Right, so when the signal did drop out immediately, this vehicle uses the crank signal as the primary for both injector and coils. So when it drops out, we see our injectors and our coils drop out immediately as well. So if we let me grab, so I did capture this the other day when I was playing with this car. I saved it. So here, oh, I don't have anything else scoped with it, of course. Oh man, sorry guys. And I think that's the only capture that I have. Yeah, I think this one just had our cam sensor. That's unfortunate. I didn't have the other two amp clamped. But I think if you scrub back in the video to the point where we were doing this the first time, I think you're going to see your injectors and your coils drop out immediately with the crank while the engine's still spinning and the cam sensor is still functioning. Okay? And then apparently when it sets a code for the crank, it has the ability to just use the cam sensor to run injectors and coils, because it started up without a crank sensor. But that's after it coded. Before it coded, it was trusting that crank sensor as the main input, and it killed injectors and coils when the crank sensor disappeared. I think that's what you're asking, Keith? Sensor not producing voltage. Sensor is basically a generator. Yes, the sensor generates electricity when it's got a magnet in the end of it, and when you pass a piece of ferrous metal or a piece of magnetic metal, steel, past it, it will create a AC voltage. Yeah, flowchart says replace the PCM. Yeah, for sure. Keith, interesting isn't the answer I was looking for. Did it answer your question, or is there a follow-up coming? Yeah, right. Put the crank sensor right next to the manifold without a heat shield. Yeah, my hands are feeling that right now a little bit, but that's part of the job, I guess, sometimes. All right. If there's nothing else here, guys, if you didn't need to see anything else today, I think I covered my point of view on an intermittent crank sensor problem pretty thoroughly. Capture as much data as you can. That's the biggest thing here. And talk to that customer, right? Don't forget about the customer. You can pick up so much information that leads you down one path or another based upon the customer's voice of exactly what they're saying. And then you can also tell if they're lying also, right? Oh yeah, my car never did that, or this problem never happened, or blah, 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 blah. Okay. One more time with the t-shirt question in case you haven't already sent me an email with your answer. There it is. Should Tech A, is Tech A doing it right by doing a fuel quality test, or is Tech B doing it right by checking for evap codes? Who's got the most valid path? Send an email out on the bottom of the screen over there, pointing down that way is my email address. Everything's backwards on camera. Down that way, mcbecker@ngksparkplugs.com. Send me out that email. First 5 people today that get the answer correct and explain why the answer is correct will win one of our awesome t-shirts. So I think that will do it. I really appreciate everybody being here, hanging out for this, what I thought to be a really interesting diagnosis. I really appreciate it. If you haven't already, please give us that thumbs up. If you have questions or comments at all, or just want to say, hey, thanks, go ahead, leave that in the comments box below. If you're not already a subscriber, please do that, so that way you get notified when a new one comes out. The next one is going to be August 1st. August 1st will be the next class, 11 a.m. I think we're going to go ahead and do that European wideband sensor class unless something else comes up that's awesome before then. This one kind of pushed that Euro class back a little bit, but sometimes we can't sit with a car down for a month. I didn't want to pull the sensor out and run into it never acting up again type of thing, right? So yeah, appreciate it, guys. Really, really enjoy having you all with me. And all right, well, thanks again for watching. We'll see you next time. Happy wrenching, everyone.